So here in example number 3, I have some really crazy numbers here, 7 and 6, a 3, a 4, and a 28. These numbers are big. But given I need to create a line that is perpendicular to this line given. First of all, I need the slope of this equation. And I hope you still remember the fact that we can find the slope of a line using negative a over b. I don't need to draw it. And even if I'm to draw it out, these numbers do not give us nice number at the end. So I will simply come up with the slope at this point. Negative 3 over 4. And the line that is perpendicular to this would then be negative reciprocal, giving us 4 over 3. Knowing how this perpendicular line will pass through the point 7 and 6, with the slope and the point given, I can now create the equation of this line using slope point form, with y minus y1 equals m times x minus x1. Once again, these numbers will not be nice, but maybe I can do something about it. Looking at the question here, I have a fraction for the slope. If you don't like working with fractions, multiply your denominator to the other side. And that will give us 3y minus 18. And on the other side, with 4 times this, that will give us 4x minus 28. And bringing everything to the same side, I have 0 equals 4x minus 3y minus 10. So this is the equation for one line, for the perpendicular line. And if I have another equation here, well, let me solve this system of equation by elimination. One equation, I have 3x plus 4y equals 28. And the second equation here, I have 4x minus 3y equals 10. I can solve this system by making a multiplication here. I can multiply the first one by 4 and the second one by 3 if I want to eliminate the x. So in this case, it would give us 12x plus 16y equals 102. Actually, 112. And for the second equation, 12x minus 9y equals 30. And as I eliminate the x, I will end with 25y equals 82. And this gives us the y coordinate. Not a nice number, but it's okay.
What is this coordinate for?
That would be the y coordinate for the point of intersections. And I can now calculate the x coordinate of the intersections by making a substitution back to one of the equations. With 4x minus 3y minus 10 equals 0. If I have 82 over 25 for the y coordinate, you can then calculate the x coordinate. And once you have your x coordinate, here is my y coordinate, I can now calculate the distance between this point and that point using the distance formula. That's a lot of work, that's for sure, but there is a much better way to solve this kind of question without doing all these work. like similar to example 1 and number 2, I can use a really short formula to calculate the distance between any point to a line. And this is the equation that you will learn in grade 12. But I'm going to give it to you for now. Here is the equation. If you don't know what that two vertical lines mean here, that simply means absolute value. And basically the idea is that when we are calculating the distance of a line, the distance from a point to a line, you want everything positive. So if I can take the absolute value here, then we will come up with a positive result. Here we have A, B, and C. When you look at this equation, it looks pretty much the same as what we've seen in the past. When you want to describe a line using the general form, we used to have ax squared plus ax plus by plus c equals 0. Sometimes when we describe an equation of a line, we have something like this. It doesn't have to be y equals mx plus b. It doesn't have to be slope point form. I can expand the equation, group the like terms together, and make my equation in this format instead. With A being the number in front of x, B being the number in front of y, and C being the constant term of your equation. Seeing how we have the 28 on one side, bring it to the other side, it will give us minus 28 for this equation. So here, if you make a substitute, A equals 3, B equals 4, and C equals negative 28. Using the point 7 and 6, if these are the numbers for the x coordinate and the y coordinate, substitute these two numbers into it. And of course, in the denominator, if we have A equals 3 and B equals 4, you can use your calculator, simplify the values, and this is how I end up with 3.4 for the distance. That saved you a lot of work, getting the distance from a point to a line with just one single formula. Now, of course, on your test or your worksheet or whatever it is, at the end of this unit, I probably will come up with part A, part B, part C, get you to come up with the perpendicular line, equation of perpendicular line, get you to find the point of intersections, and therefore find the distance between 2 points. So I'm not going to have a questions like this where you can simply use your equation to find your answer right away. But this is one formula that you can use to check your work instead.